Hello. Okay, now it's good. Yeah?
Good.
Yeah? Everyone hearing me? Great. So, first questions. Who was here last year? Okay, it's like 20 people. Okay, I want to see you next year, then all of you. Will be great. I'm going to talk a little bit about Docker. So just to have an idea who is using Docker here, either for development, production, or... Nice. Okay. Let's see if it's going to be interesting for you. I know I'm the only thing between you and the after party, so I'm going to try to be really fast and then do not piss you off. But who was here last year, remember what I did, and I want to do it again. So please, if everyone could stand up, just for a tiny second. Yeah, just stand up. Let's put this energy off. Move your arms. Just move your neck. Let's get ready for the after party. And then... Well, yeah, and then we are going to have a second thing, which was really good from last year. We are going to make a group selfie, right? We do that because if my talk is not good, then afterwards you're all going to be like bored and etc. And then we do it beforehand just to guarantee, okay? So make your happiest faces. Let's make it happen. Yeah. Okay, that's a lot of people. Well, everyone energized? Ready? I need you to pay a lot of attention because I'm going to do live coding. And, well, if it goes wrong, I need you to tell me what to do. Okay. Okay, let's talk a little bit about a classic Dockerfile. Oh, sorry, my resolution is not so good. But if we go now to the Docker Hub, they have like official PHP images, right? So you might have seen this example there before. It's just like a sample of a PHP FPM using Debian as a base. And then this example looks pretty good. But can you already spot any problems there? I can tell you that it runs pretty nicely, but a few things can go wrong. And the relationship I want to make here with those Docker is just like what we do with our PHP code, right? As soon as you start coding, you run like a PHP code sniffer, CBF, or PHP CS fixer. You just want to make sure these things are pretty nice. So if we can spot a problem, so why don't we like also use a linter inside our Docker? So if we lint that archive, that file, we are going to see something like that. So it's basically saying you should quote variables because in shell, if you don't do it, it can have word splitting, which means you can break your build, or someone can inject some malicious instructions in your code, just like in PHP. You should lock the versions in your apt-get or apk add and things like that. And you should like remove cache, and you should make sure, like in this case for Debian, that you're not installing a lot of packages around it that you don't need. So let's use hadolint for that. That output you're seeing here is from hadolint. And you can see there are some funny codes here, like SEC something and DL something. What do they mean? So SEC stands for shell check. So what's happening is every run instruction you have inside the Dockerfile, it's being checked by a shell check. And shell check's like, hey, you have to quote variables, you have to do this, that's not how you do loop or functions or blah, blah, blah. If we open that link, we can see a complete description of that error we have. So basically, every code you have in your output, you can just go to this wiki page inside GitHub and have some extra information about it. And the second prefix, the DL, stands for hadolint with the same style. So you can basically just come there and understand, oh, you should pin the versions because you want a predictability, right? Every time you build a Dockerfile, you want to make sure you're building with the same versions. And that's basically what it's saying. They have like shell check has, I think, hundreds of checks. Yeah, 330, while hadolint has like 37. So our example was pretty good. We only had a few issues. So let's do some live testing on that. I'm going to create an Alpine version of the file. It's basically the same. I'm just using Alpine because it's smaller and faster, of course. But it's basically the same code. The only difference is like a few of the packages have different names, right? So let's run the hadolint inside that one. And since this is a Docker talk, we are running inside Docker. We don't want to install anything in your computer. So basically what I'm going to do here, I'm going to run a Docker container from hadolint themselves. And I'm going to send within my standard input the Docker file that we have. So we see here the same, exactly same output, right? The difference now is a little bit because it's saying use the -- no cache because it's about APK and not APT. and it doesn't have the problems with install recommendations. But let's fix this file, right? So let's start applying those things. So if we get this file here, oh, I can't really resize it, but in here is just like some libraries. So it's saying, okay, let's use -- no cache. Let's do it. We just do it, and then we run again. Now we have only 2 problems. Great. Let's now quote, because it was saying like, hey, you have to quote the variables. The only place we are using variables here is in the compilation of the PHP extension. Those helpers come from the official PHP image, and that's basically if you want to install, for instance, iconv, MySQL, Redis, or Mongo, you have to use those helpers to help you out on the official images. So if we quote this variable, yes, also here, and then we run again. Nice, we have now just 2 problems. But then there is this a bit harder part. It's saying, hey, inform the version that you want to have in your packages, in your system packages. The way I like to do it, I basically just go to the packages.alpine, which has like everything about Alpine packages. And then I see the packages that I'm using. So for instance, yeah, free type dev, right? You get this package, and then we are going to put it in the search. And then we can see exactly which version is running. So you can basically just copy this version, and then you can go back to your Dockerfile, put equals here, and then it works. We can do the same now for the other 2. Oh, sorry. So libjpeg and libpngdev. Let's do it. So then basically now we hope to have a green on the corner because it's still failing. So yeah, nice. So hadolint now says our Dockerfile is ready to start being built, right? That's pretty much what we do in normal development. So I think it's really valuable. And there is just one tiny problem because, well, okay, what happens if you want to ignore stuff? I'm not saying you should. But APK from Alpine, it has a huge issue, which is they only maintain one last version of the packages you are installing. So what's going to happen is that when we come back to our Dockerfile in 2 months, those versions are not the same anymore. They are now version 3, 4, 5, and your compilation of your Dockerfile is not going to work. So how do we prevent that? We can't, because it's still an Alpine issue, but we can ignore this rule, for instance. So let's do that. I'm going to revert this to a version without the versions locked. If we try to run, it's going to now complain, like, hey, you shouldn't do that. And we can simply say -- ignore DL 3018. Oh, sorry. Yeah, that's not going to work. What we are going to do actually is create just a configuration file, just like what we do with PHP-CS or anything. So let's do it. I'm going to create here .hadolint.yml, and this file we can open it here, and then we can just put ignored DL 1318. Was that it? Yes. If it's getting hard to read, you just let me know, and then I'll put the terminal up like this. So then we can all keep in the same page. So what's going to happen, it's not able to detect our change, right? And that's because we are running like this binary version of the Docker image. So we want to use something that allows us to pass this file together with our Dockerfile within the Docker we are running. Oh my God. So we are going to use a Debian version of it. We are going to now invoke manually the hadolint binary inside the image, but you also have to find a way to share your files together with the Docker which is running, right? The Docker container. So we are going to mount a volume from our current directory, and then we are going to mount it /p as read-only mode because we don't want to allow hadolint to use our stuff. And that should be able to mount it, and then we want to also change our work directory from this thing to /p, which is this directory. And I did a typo on my hadolint file, of course. It should be ignored. Oh, yes. See, you're not paying attention. Didn't tell me what was wrong, huh? Okay, so now we got a green again, and this time it's something we can actually manage. So if you actually opt for ignoring something, that's how you do it. Well, you shouldn't ignore it. That was some way of knowledge for you. We did that already, so let's just move on. So let's say now we have this lint running, and then your company is also looking for a path of upgrade. Let's say you are using now PHP 7.1 and you want to go to PHP 7.2, or from PHP 7.2 to PHP 7.3. What you see a lot of people doing, they just like copy these Docker files around and prefix them, and then when you're running like a Docker build, you just like have these multiple files you want to manage. Of course, that's not ideal. If you want to like have something automated, have a build. So what we are going to do here, we are going to try to change the version of the PHP we are compiling at runtime. So if we take a look inside our Dockerfile again, it's compiling PHP 7.1, all pretty nice. But we want to change that number up there to PHP 7.2. So how we can do that? Well, we can use simple Linux commands. So we are basically gonna call sed, which is a text editing command line. And we are gonna ask them to substitute part of our text. So we are gonna basically look for from anything, and then we can just change now to from PHP 7.2 fpm alpine. Oh, alpine, and inform the Dockerfile. So basically we have now a Dockerfile which doesn't exist, like in your storage, in your repo, but it still can change the version. So how can we build this thing which is just now in the temporary memory? We can use some other Linux powers, so we can pipe this file towards the docker build command. So how we're gonna do that? We're just gonna do docker build. We are gonna choose a tag here, /php, in this case 7.2. And then in the file part, we are gonna use this, I have to put it up, sorry. We are using this simple dash here. What this dash is doing is basically taking the standard input that we are piping before and pretending to be a file inside Docker build. Let's see if this wizardry works. Seems like it does. And you can see like we see here from PHP 7.2. So that's pretty neat. That helps out. If we want to test if that's really true, we can just run this tag. We can just copy the tag we just have created and do a php-v. And we have here PHP 7.2 built with the same file as we had on PHP 7.1. And we can just go forward, right? If you want to do like the 7.3 RC and you build, again, it just does the same procedure. Oh, wait. That's the tag. I have to change the text replacement as well. Yes. Yeah, so now you can see it's building from PHP 7.3 RC. We can test that the same way. So if we do a Docker run, and then we change here to 7.3 RC, we are able to test our PHP 7.3 version. So that can really help you on maintaining just one thing and make it really easy. But of course, we don't want to execute all these crazy commands all the time. So I'm going to try to play around with makefiles. Anyone here using makefiles at work? Yeah, playing around? Nice. So before Circle CI, Travis, or GitLab were cool, people were already doing makefiles. That's basically a build automation tool that you can use in your development. That's really common if you're compiling something. You always have like configure, make install. That's basically what we are going to do, something similar here, but without the configure. It's not compiled. We're not compiling Docker files. We're just making a simple thing. So let's do it. Oh, sorry. I have now a base Docker file here, which only has the linter from the previous one. I don't know if I can do a better. Let me see. Can you read it properly? I don't know if this is better. Is this more readable or the other one? People in the back? The previous one, right? Okay. The only problem with the previous one, it's like, it's not allowing me to change the size, but let's see if we can break some lines here. So what we want to do, we want to get automatically the sed command we have created. We want to make sure we can build that in a more dynamic way. So let's call something like build tag. We are going to just copy what we had before. Let me break it in a few lines so then it's actually more readable. Yes. The Docker file there is fine. But we also want to make sure that we can pass dynamically these tags we are building, right? So let's create a variable in our Docker file, just this. And then we can replace now 7.3rc, for instance, with this variable. So we just come here, build tag. Then we can copy this one here. Oh, sorry. And then we are also going to automatically tag it here. So we have our completely built running. So how we can test that? Now, instead of running all those commands, we can do a make build tag. We can inform the tag we want to build. Then in this case, let's do 7.1. So basically, it's doing for us automatically now the text replacement. We can go forward. We can just now use 7.0, 7.1, I don't know, 7.1.20, whatever. You just like create this really easy way to create custom PHP versions for yourself. And it just works. So if we do again the Docker run trick here, we can copy the tag we have just generated, and then we have a PHP 7.1.20. This is really helpful because if you are maintaining various images, or if you have like a lot of PHP projects in your company, then this helps you. Like if someone can't migrate to a certain version, you can just create some patches, and that helps in your maintainability as well. But we wanted this a bit fancy. Let's see what happens, for instance, if you don't inform like the tag. This, of course, is going to break everything, so we want to make sure this argument is going to be always there. So we can say, like, if build tag is not defined, then throw an error, which is going to be, please inform build tag. And then if we try again, now we have like just an error file. So that's a really simple way to start automating our stuff. But we also want to have a way to keep what versions are we actually building, right? So what we can do here, basically we are going to create a new target, and we are going to call the build tag itself. So we are making an internal make call. And then we are going to inform here build tag. And then let's say we want to maintain, as we said before, 7.1, 7.2, and 7.3. So I can basically just come here and make build. Oh, I forgot to call the build tag target. Live demo. Oh my God. Let's do it. Yes. So we can do that or not. Build tag command not found. Oh, yes. I did that part wrong. There we go. Yes, so, whoa, that was fast. Oh, that's a wrong version. We want to RC here. So basically this way we can keep like building more and more stuff, but we also want to keep track of like what have we built so far, right? So one idea, something you can do, which is pretty simple here. Of course, you can go more fancy as you have like more stuff to do in your company, like more challenges. What we can do here is just create like a temporary file, like tags.list. And then, And then we want at the end of our build, if it succeeds, so we do an end, we want to do an echo of this, this tag here. We just want to put inside that file. TMP tags.list. So then now when we build, we should be able to see a file inside our TMP directory, which all the builds we have just done. So that can help you out further in the process to keep track of everything that is happening. And from now on, let's say like someone said, oh, I can't really migrate from 7.1, I'm stuck on 7.1.20. You go there, okay, I can do that for you. Then you build, and then you have like that thing already done for you. Of course, ideally, you're going to move that to a CI, something that can automate even more. But you get the grasp on how to do that. So let's continue on that part. Well, that's basically what I've done if I have failed my, my live demo. Some other really important parts that I see when you are like maintaining various images, and then what happens is like usually you just do like this Docker push to your container registry, wherever you have it, and then you never look back to these old tags anymore. And what might happen is that your images, old images that are still being used, they're just getting more and more vulnerabilities. So we are going to use a tool here called Claire. It's created by Core OS. They're really participative in this whole operating system and Docker scenario. And let's just see what this tool does. It basically looks into the CVE databases, which are the known vulnerabilities that people can report, and then you fix that. And then it downloads all the CVE databases and then exposes an API that we can just send our Docker images and then look for the vulnerabilities inside of it. So it goes through each of the layers. So you have one layer contaminated, but another one, it's going to be able to go through all the layers so to give you even more security. And then we can use a simple CLI tool called Clair Scanner, which can like send your Docker images, and then I get it. I can also write to a log file and everything. So let's make it happen. To help us out a little bit here, since Clair is like a whole system, we have to deploy it somewhere. We are going to use a Docker Compose file here. You guys use Docker Compose? Yeah, so this is going to be quite simple. So basically, we have a Postgres database, which is the one which is holding all the CVE databases that are known. We are giving it a name, Clair Postgres. And the fact we are using this special image here called armin-c clairdb latest is because loading all these CVEs takes like half an hour or so. We don't want to wait here half an hour just to build our tool, our demo. And the other part is the API itself, which is exposed in those ports, as you can see here, yes. And then it links to Postgres, so then we make sure that we can have this API up and running with all the CVE databases there. So I have already this file on my system. And we are going to do a Docker Compose. We are going to form the file. I've put it inside test, security, Docker Compose. And we are going to do a nup on it. So basically, it created now first the Postgres. Now it's just scanning all the databases and everything. I'll just invert this for better readability. Yes. OK, so now we can use the Clair Scanner CLI tool to check one of the images we have done before, right? So if we check our tags, we have like this tag here that we have built already. We can call Clair Scanner --IP. In this case, I have to inform the IP of my Docker host. If you have like Docker for Mac or Windows, you use just a different host name. Doesn't really matter. And the tag we are using. I couldn't find my image. Great. Yeah, let me just build this again. Yes, build tag. Oh, damn. Let's try something else. Damn. OK, it's failing on a second one. I don't know exactly why. What is the tip? Yeah, it is in there. But somehow it didn't work. Live demo, right? Oh, it's duplicated now. OK. Trust me, it should be working. Let me see what I can do here. If I can just build everything again. I should have also a Clair Scanner shortcut somewhere here. Oh, I think I know what's wrong. Wait. Yes, I informed the wrong IP. Thanks, Linux. OK, so you can see this image. The 7.3 has no vulnerabilities. It went through all the Docker layers and got you like in the end, hey, you are all good, right? But let's see if we try to use one version older, for instance, 7.2, still all good. 7.1, still all good. But let's say one of those patches, one of those patch releases that we had in the past, which I didn't build, of course. Oh, it was 7.120, right? Yeah, so what happens, it shows you like what is contaminated. What happens here, it's saying like, oh, hey, there is this vulnerability inside curl. You can just click on the link. It's aware that it's an Alpine package, so then it already gives you the version that has it fixed. So we come back to that problem in the beginning. Do you want to put the version in your APK add? One of the solutions that I use in this case, I just do a APK update. Because if you lock the version in the future, this build is going to break because it's updated again and Alpine just doesn't keep track of it. And then you can see more details of the CV, just links it for you. And then you know who is affected. And then usually it's like a library like curl affects like so many distros and so many things. It's such a crucial point, right? Because libcurl is going through all the requests you are making, basically almost all of them. So if you have like so if you have file get contents or whatever that's making API calls, curl is in there. So look at the size and the dangers of this vulnerability that you never knew was inside your Docker containers. So that's something pretty cool. What we can also do here, if we turn down this, we can also automate that part, right? Because basically what we have is our tags.list. So if we check it again, so now we know everything that we have to build in our system. We know how to spin up declare. So we can basically come up here. I'm going to give it a name just for declare CI or so. Just something, because the advantage here is that if you give it a name, you have predictability of the name of your containers that Docker Compose is doing. Did it quit here? Okay. I don't know if it's still working, but let's check. Oh yeah, it still works. So what we want to do again is get that list that we have created and send it within the file. So to do that, would be nice if we could just replace our tag with something like this, just like a placeholder. And we can do that using the xargs, that beautiful Linux command. Also GNU and other styles. And then we can just say like, what is the replacement string? We are going to use the percentage here. And we can inform it where it should get the data from. So we get tags.list. And then now it's going through all my items. And then in the end, you can see a lot of vulnerabilities. And then in the end, I have like a failed build because, well, we found some vulnerabilities. We can also play around and put it inside our Makefile. So if we open here a Makefile, we still have like our build tag and everything. Here, there's just a tiny difference. I don't know if I can make this better to read somehow. Okay, I'm going to leave the presentation mode for a second. Yeah, so basically we are doing the same Docker Compose up command as we had before. Here I'm just creating like a for loop waiting for the API to be available because we have to ping that specific port. And I'm doing the xargs trick just to run over all my build images. So how else can we make this even more enjoyable for when you are developing? So we had before already the make lint, right? That does that for us. We have the make build that also builds all our images. And then let me turn this one down. And then what we can do now that it spins up for us, we can do the make scan vulnerabilities. Then now it's spinning up our Docker Compose. It's going through waiting the API to be available and scanning everything. You can make it even easier because if you check here, I have a make all target, which I can basically come and say, hey, lint, build, and scan vulnerabilities for me. At the beginning of the build, I'm cleaning the tags.list. So we have like these fresh versions that you have just built. And then we can basically guarantee that using make all, you're going to get, oh, not guarantee, but would be nice. What did I do wrong here? Build. Oh, yeah, I touched this thing. Yes, sorry. So we can do like a make all here. And then, well, it's linted our image. It built everything. And then it's not scanning for vulnerability. So the idea here is that it's getting closer and closer to how we do software development with PHP or any other language, right? That works pretty neatly. Since I've put the make all here on the top of my file, we can also use another trick because make uses the default target as the first thing you declare. So basically, someone is starting on the project, you can just run make, and then you have everything running. So I'm stressing a bit on the make part because that can be useful for you using PHP project as well. You don't have to do that just for this sample. So if you have like PHP CS and a lot of things that you do like Composer, run scripts, or things on that size, Make's gonna make it really more flexible for you to play with it. So great, let's go forward now. We have linting, we have building, and we have our scan vulnerabilities in place, all automated. So I want a wisdom moment, which is please only push the tags you are maintaining. Because you saw what happened is that the official PHP images, they keep those old tags there, like 7.1.10, 11, to 20, 21, 22, and they never update them back. Even though they could just rebuild a minor version of PHP, a patch version of PHP, but they never do it. So if you are maintaining it for yourself, or if you have like an open source Docker image that you have, please make sure that you only pushing the things that you want to maintain. And with that strategy of make files and everything, gets it really easier to do it. But now, what if something happens? For instance, the official PHP image comes and deletes the entry point script. Because when you depend on someone else's image, you basically have to trust that everything that was inside that image is still there in the newest versions, right? You're currently pulling it and building your own images, what's happening there. So basically, we should write tests, right? But how do we do that with Docker? Oh, you should also test your tags. Don't be like PHP official images. Not trash talking, but we can improve it. We are going to use test infra here. Have anyone heard of test infra before? No? Okay, so you are learning something new today. Look at that. You have some question? I saw your... No? Good. So test infra is basically a PyTest extension. PyTest is the PHP unit of Python. And a test infra basically allows you to connect into a running machine, in our case, a running container, and execute a few things inside of it. So we want to go inside our containers that we have built, and we want to check if the things we need to run are still in there. Let's build a simple example here. So let's come to the part 5. I've done a small pre-setup here, which I have a pytest.ini file. Basically, the only thing it's doing is telling pytest where to look for the tests. In our case, we are putting inside container anything.py. So we are going to come inside container anything.py and create something.py. So let's do it. So we are going to test, I don't know, the helper script, right? That's what the official images give to us. So we can start by importing pytest. Oh, sorry again. Every time I press ask, it leaves the presentation mode. We are going to create a new function, which is going to be a test. So it's going to be test. Scripts are there. And we have to pass one thing inside, which is this host. Host is basically going to be what the connection you are giving to it, like the running machine, the running computer, the running container, whatever you have. Let's first locate where those things are, right? Let's see the tags we have here. So let's go for the 7.2, 7.3, doesn't matter. Let's go inside this container, and let's see what do we need from it. So we can basically sh inside the container. So we got a connection. We see it's like inside var www HTML. And then there is those commands, docker -php -extension install. Because if we look into our Dockerfile, right, we have the extension install. So we depend on that to make sure our building succeeds in the future, even if we pull newest versions from the official Docker image. What we are going to do is just extension install here. We're going to run which command, which just tells us where this thing is. We copy this path. We are now coming to our file. And then we are going to call this host thing. We are going to call an assertion first. Host.file, and then we are going to inform the file path dot exists is true. Okay, so just so you can read it all. So basically, we are just like getting the connection for our running container and checking if this file is in there and everything is okay for us to proceed. But how do we get this running container, right? We can basically do the same like docker run, but then this time we do -d, which is basically going to demonize this Docker. So this is the identifier within your Docker. So if you do a Docker PS, you can see it's in there. Let me just bring down this one as well, so then we don't have any pollution. Yes. So we have Docker PS. We can see we have PHP FPM running, exposing port 9000, which is the default PHP port, PHP FPM. And then now we want to see how to test that. So again, we are going to use more Docker images because we like that. This time we are going to use a test infra image. And we want to inform to it which host we want to run. When we do that, we can just inform Docker as a prefix for the hosts. And then we expect it to be able to run it, but we still have to give our tests to them. So our tests are located within /tests, or /test, I'm sorry. So we are going to take our current directory and then mount it to tests as read only, and then fails, of course. -vrmit. Yes, I just didn't type the most important word, Docker run. Okay, so it's still saying, hey, I can't talk to your Docker stuff. Because what happens is like we have to give PyTest and the test infra permission to run through our Docker images running in our computer. So what we are going to do here is not just mount the tests. I'm going to give access to test infra to my Docker socket. So we can just mount the socket, so then it can do that. So it's inside my var1 docker.sock, if I'm not mistaken, and we are going to mount the same thing inside our machine, and we get a test passing. So really simple, you can just keep that, and then you see what's happening. So we want to expand this test, for instance, and just, let's say, we want to test all the files, all of those. We are going to do extension install, enable. We also want to make sure that this thing has the right permissions, for instance. So we can like see what is the permission. So like this is like a 775. So let's go there and let's do like, let's say it has to be an octal of 755, because that's the permission we have. Wait, I have to remember dot permission. I forgot. Just give me a second now. Cheat mode, yes. Maybe, yes. Let's check it. Oh, I'm still inside my Docker container. No, I'm gonna check my my working version here. Mode, yes. No one saw that. Okay, so we have mode, and we are able to test it, or not, because it's not the same value. Oh, it was 775. Yes. And we get passing again. Good. So now we want to test multiple files, right? So the same way PHP unit has the data provider that we just go through a loop, we can use PyTest parameterize, this name, I know. And then we can just give it a name, right? And then in this case, it's going to be like script. And then we can pass a list of files. So basically, we want to get first this file. Just remove this parentheses. And we want to also put extension enable. And now we can basically type hint here script, which is the same name as we had in our parameterize. We can put it here. And instead of putting the files itself, we just pass script here. And then a script here again. And then now, hopefully, we have some extra tests. Yeah, nice. So it collected 2 items and ran 2 tests over them. So we can just keep going. We could just put like the whole list. Let me see. I want to do something else. Yes, I want to do something else. Just a second. OK, so I want to make a change to our Docker container. Instead of exposing port 9000 and doing FPM, I want to use the socket, right? Because it's faster. So I want to make sure my Nginx can reach the socket file from PHP FPM instead of going and then having to connect via TCP IP. I want to remove that clutter from it. So what we are going to do, I'm going to change, I'm going to import this file here. This is it Docker. I'm going to, in my Docker file, copy it. So we can see it here. So basically here we are copying our configuration from FPM and putting it inside the container. So then the first thing I want to do is just make sure this file is going to be inside our container. So let's write another test. So def test FPM configuration. Then I will pass the host again. And then we are going to assert host.file. And this time we are just going to do this /z docker.conf. This is docker.conf. .exists is true. OK. Let's run it again. Let's see if our Docker thing is in there. OK, it's in there. It collected 3 items. It tested our configuration is there. But I want to make sure my configuration is there. So what is in? Oh, let me just close some stuff here. It's getting a bit too much. Close others. And here we want to make sure that the content of our file is also there. So let's say we want to make sure that this text is inside our configuration. How we are going to do that is by also doing a assert, and then we paste the string in, because that's Python syntax. We want to check if a certain string is inside the file. So then we are just going to copy this one and content, right? So now we are asking, hey, check if the var run PHP sock is inside our new configuration file. Hopefully, this is not going to pass. So it didn't. Great. What's happening here, right? We have bootstrapped a Docker container before. So basically, we are still running the same instance of Docker, but we are doing changes on it, and we want to make sure it's up to date. So I'm going to stop this one we have created. I'm going to build again the version 7.2, because now I have my configuration file in place. Is that correct? Yes. So I've built it again, and now you can see it's copying the file inside our configuration. And now I have to run it again, right? So let's do a docker run -d. Yes. Let's run the same image. Now we have a new running container, which we can basically paste again inside the hosts file. And hopefully this passes. So basically you can slowly do it. Of course, I'm not going to leave you without some automation in that part. Let me just check the time. Oh. Okay, we've been 40 minutes through. Are you getting super bored already? Surviving? Yes? It's okay, nice. Okay, so we know the configuration is in there, right? But is this configuration working? That's another question. So what we want to make sure is not just our configuration contains that text, we want to make sure the socket actually exists. So we are going to do again the host.file, and then we're going to put there, and then ask exists is true. Well, let's hope this is correct. So then we have one more test. Yes, nice. So let's this time do something different. Let's get inside our container. Let's exec into it. Let's copy the running URL. Let's sh. Okay, we are inside the container, and we have the var run PHP FPM sock, right? Let's check, for instance, which permissions we are expecting from it. So we are expecting this thing to be owned by root, and I have a permission 666. So you basically just could come here and then start doing the same procedure of like guaranteeing that the user using the socket is correct, that everything is pretty nice. I have this example here. I'm just going to do it so we save a couple of seconds. But basically, it's the same. I just added all the script files, and then I just make sure that the mode of my socket is in here. And then let's also hope this one works. Yes. But of course, we like automation, right? So far, we have manually started and stopped this container from running. We want to use our build tags that we have created, right? So how can we do that? So we have our tags.list. We want to make sure that every tag you're building, all the tests are passing. So let's go through the whole CI process, make sure everything works pretty nicely. So what we can do here is basically automatically get the tags and then spawn Docker containers in -d mode, so it's saved, and then we can turn it down later. Since we are short in time and I have still one thing more to present, I'm just going to show you how this Makefile is looking like. So basically what I'm doing here, I'm creating a variable container, which basically just does the docker run --rm we did manually, right? And that returns the running container ID. And now I'm going through all that we did before. We mounted the tests and everything, all the same, mounted the socket. And this time on the hosts, instead of passing that string manually, I'm passing that variable. So we can now mount it. And then on the Docker, in the end, I do a Docker stop, because I don't want all these crazy containers for my tests running in my machine all the time. So we can basically do a make test. And now it's spawning one container. Oh, one of them failed. Great. It's spawning a lot of containers with all the tags that we had inside our build, and making sure that happened. So what happened here? A few of them failed, right? So let's see why. So basically it's saying, hey, I couldn't find the socket configuration. I'm actually finding listen. And that's because after I did the change of the configuration, I didn't build everything again. So if we do a make build, and hopefully our make test is now past 100% of our tags. Great, it's working so far. So then you can just like, from the beginning, like start creating these tags, keep maintaining it and going forward and forward. So now there is one more thing I want to tell you about. This is all we did, all live demo, great, luckily some worked. But what if you have like moving parts? Because the example I just gave you was about moving our FPM from listening to port 9000 to being a socket, right? How can we test this thing is working from the Nginx perspective, for instance? Because you're going to have your Nginx container, you're going to do the same building process as we did here. You're going to change your virtual host to point to a socket file. So how we are going to like test that? Let's do functional tests to the rescue, right? That's the same we do with our PHP code. Let's do it here as well. Basically, what I'm going to do to make it happen, I'm going to use Docker Compose again. Let me just make sure everything is dead here, yes. So basically, with Docker Compose, what I'm going to do, I'm going to show you the file instead of typing it. So let's go, part 6. We have all the same configuration and everything. And I'm going to just rename this one so we are safe and sound. Okay, so again, another Docker Compose file. We are using one of the tags we have built before here. And what's happening is, okay, Docker Compose, run this image that we have just created locally. And you are going to share some volumes. So I've created the named volume here, which is fpm-sock. And I'm mounting this thing inside my var run. So then I can get the socket to my Nginx container. And I do the same mount to our Nginx container. So then Nginx can actually reach our socket and have no loss in performance if you want to keep both containers separately. So let's test that. We can just do Docker Compose up. Let's pass the file first. Docker Compose. Then now we are going to do an up here. Okay, it has created. Nothing has crashed. Great, luckily. If we go now to localhost 8080, we have our running Nginx with just the PHP info there. So how do we test that, right? We want to now test something within Nginx to see if the FPM is always alive and sharing its socket to us. One thing that Docker Compose does for us in this case is predictability. If we look into what has ran, it's saying, hey, I'm creating here for you the test FPM, test PHP FPM _1 and test Nginx 1 as well. Basically what this means is that if we come, let me just invert these as well. Yes. So if we get the same command now and do a PS. Oh. Yes, wrong part, 6. If we do a PS, we have a name of those containers. So instead of using that huge container running ID we had before, we can start using names. So it's actually now predictable. So you can mix and match with versions or anything that you want to. So we are going to do again something really similar. We are just going to create another Python file. We are going to call it test nginx.py. Same procedure, import test.py. PyTest, and then a test Nginx can reach FPM socket because we are verbose, right? What I'm going to do for this test, like it's not like you have to do it, but just to make it pretty simple, we can do a host.run. Host.run basically gets this running container and executes anything inside of it that you want to do. We are going to run wget just to download the default page. Localhost, because we are going to connect inside the Nginx container. So you can just make a download of the localhost page. We want to put it quiet. We don't want to output. And we want to put it to, I don't know, output file, just a PHP info file. There we go. So we want to make sure this runs. And then we want to make sure the output of this command is 0. Equals 0. So basically this is the exit status, right? So if wget succeeds, it returns the 0 status code as Linux and other operating systems does. Let's see if we can make that happen. We are going to do something really similar as we did before, just call the test infra stuff. But this time we are going to use our beautiful name that we had before, test Nginx 1. Oh, my time's finished. Okay, so you want 5 more minutes? Is that a yes or no?
Take 10 minutes more.
10 minutes more. You want 10 minutes more, or you want me just shut down? It's okay? I can't hear. Yes or no? Yes? Okay, great. Let's do it. It's container name. Yes, it's. Oh yeah, I can even influence even more. Great. Yeah. So we can. Yeah, that's a great idea. So we can even make the names easier. For now, we can just use this one, and then we get the output. So this means basically it's outputting the PHP info to the file that we had before, but we want to make sure, for instance, currently we have PHP 7.2. Let's just make sure this content is in there, right? So we are going to do the same, assert, PHP version 7.2.11. This is not the test you're going to do in your real life, of course. You have better things to test. But to make it easy here, and then we can do a host.file. We have said the file is PHP info, right, from the output from the wget. And then we just say content. I think so. Let's run that. Yeah, so basically it's going inside our container, getting this file, PHP info, and checking the version is 7.2.11. If we change it, we should have a failure. Yeah, great. It can't assert this version exists. In our case, since we have many images, what we would do is just like 7.0. But I mean, you are going to test cooler stuff than just the PHP version. I'm pretty sure about it. So basically, this we can guarantee that like if someone messes up with the user inside our container, if someone messes up with the socket permissions or anything, this stuff is simply going to be caught on test. And then you have the safety to move forward. We can also automate that. We can use a makefile. I'm not going to write it down because my time is running out. But basically, we are doing the same thing again, just the same strategies. I'm going to have like a test tag, which runs the container and then stops it at the end. And then we have all the test things pretty beautifully. And that basically sums up the functional testing. Yeah, that was it. I'm just over 2 minutes. I've been writing a lot about Docker stuff. So if you want to check like this progress of this talk, I'm writing some articles on testing, and then it's going to get a bit more deeper. For now, I only wrote 2 parts. So it's the linting and the scanner for vulnerabilities. But later, I'm going to put more into testing and functional tests. And that's it. An overall thank you for you guys.
Thank you, Renato. У кого-нибудь есть вопросы?
And the questions, of course. Yes. Please ask questions, otherwise I'm going to
Ребята, у
think
кого-то
it's
есть
bad.
вопросы или все устали?
Thank you, Renato.
Thank you.
I have a question. There is approach when you should fix the image
Yes.
that you use, that you extend. I saw that you used actually native images from PHP,
Yep.
but is it just for an example, or you use this in real life? So do you use custom images?
I do my custom images based on the PHP ones. I just make them a bit better. So like I create my own helper scripts that does a few things more fancier, because the problems with the Docker PHP images, right? Let's go to Hub Docker. If we check, for instance, the last time they have pushed tags, of course now it's good, 2 hours ago. But usually they take like a couple of weeks, 3 weeks to push new tags. And you can see even the Docker run detects those images are with vulnerabilities. That's a feature from the container registry. So basically what I do, I import from those, because I don't want to deal with the compilation time in my CI all the time. And then when they do a lot of cool stuff. So they make sure that the CLI, FPM, and then Alpine versions, they all work really nicely. I don't want to lose that, and then I don't want to copy that. So I basically base on them, and then I do the fixes of vulnerability on my own CI. And I also make sure that I have a few things running there, because, for instance, the source code is still inside, so that uses a few megabytes. So I do some extra cleaning on it, but that's basically that.
Okay, thank you. And second question, so everything that you've shown about this functional testing with linking to images, what is actually real benefit in comparison of integrated tests? So actually, you can test this same in suite of your integration tests. I didn't get the idea. I didn't get
yes.
the benefit.
So the idea is that you are isolating your Docker building from your software building, right? So basically, this is serving generic images and images that are tailor-made for your business. So for instance, at work, we use shush for decrypting environment variable keys because we have the secrets inside our application, right? So we have this binary inside of our image. We have a few other moving parts. So we want to make sure this is being tested in the beginning so the projects don't have to worry about it. So you might want to separate what is maybe your business application inside your application and what is just Docker specific towards something else, somewhere else. I think that's kind of the idea. You don't have to test like the browser test as I did for the PHP info. That's really something you can do in your own application. That's something different.
Okay, thank you.
And just to make the point here, you can see like the last time a few of the images, like 7.0 and everything were pushed like 11 days ago. So the official images are usually not managing them. I can show you like what we do at Usabilla. And basically, you can see it was pushed 12 hours ago, and that's completely automated build. So 100% of the images that we maintain, the tags, they are pushed every evening because we patch the vulnerabilities, we make sure everything is running nicely, and we trust the process because of the tests. So next question.
У кого-то есть еще вопросы? Thank you, Renato.
Oh, okay. Thank you.